So for the derivative rules, so far we have looked at how to derive a constant, a variable, a constant times a variable, and a function that contains different variables plus or minus other variables. And now we will look at power rule. What happens when we have a power over a variable? How do we derive that? Let me show you what I mean. Let's say we have this 3x plus 2. This is a normal function. We have derived this before. We know the rules. We have a constant, we have a variable plus another function. But what happens if I introduce a power to the variable? How do I derive that? Well, the rule for that is the derivative of a function f with a constant c and a power p not equal to 1 is cp times the function with p minus 1 power. This looks very confusing. What do I mean exactly? Well, let's say I have this function f of x equals x, and I have a power to the power of 3. So how do we solve this? Well, as I said, all you have to do is to take the power multiplied by the constant, multiplied by your already variable that you have, and subtract the power that you have over the variable with 1. So here our constant right here is 1, our power is 3, so it becomes 3 times 1 equals 3, so it becomes 3x, and here we have to subtract 1, so it becomes 3x squared. So f prime of x squared is 3x squared. As you can see, we had a constant right here. We multiplied by the power, it became 3. We took 1 off the power, it became 2. So the derivative of x to the third became 3x squared. This is basically how you find the derivative of a function that contains a power. So for example, if this 3 was 5, this function, the derivative of this function would be 5x to the fourth. If it was 10, it would become 10x to the 9. You multiply your power by the constant that you have and you put it in front, and then you subtract 1 from the power, and then everything becomes fine. So let me give you another example. Let's say we have this function f of x equals 6x to the 6 minus x plus 3. How do we solve this? Well, this is very easy. All you have to do is to take the derivative of each function, and then you find the derivative of the bigger function. So if we want to find f prime of x, what do we do? Well, basically f prime of 6x to the 6 minus x plus 3 equals f prime of 6x to the 6 minus f prime of x plus f prime of 3. You know that f prime of 3 is 0 because this is a constant. You know that f prime of x is 1 because this is only x. It's just one variable without a constant. Actually, it has a constant, but it's 1, and without any powers. The power of it is 1. And this is the only new thing that we have in this equation. It's 6x to the 6. How do we solve this? Well, as I mentioned, it's very easy. All you have to do is multiply this 6 by this 6. It becomes 36, and you minus 1 from the power. So you will have 36x to the 5 minus 1. As you see, we multiply this 6 by this 6, it became 36, and then we took off 1 from the power. It became 36x to the 5 minus 1 plus 0 because this is a constant. The derivative of a constant is 0. And eventually we get 36x to the 5th minus 1. This is how you solve power problems. When you have a power, all you have to do is you multiply the power by the constant, and then you take 1 off the power, you get the derivative. A small remark right here, and I could not talk about this in the previous lectures when we talk about that the f prime of x equals 1. Why does f prime of x equals 1? And since now you know the power rule, how can we find that? How can we make sure that f prime of x actually equals 1? Well, let me show you. F prime of x equals 1 because, as you can see, the power of x right here is 1. When you apply the power rule to this x or to this variable, you have to do the exactly same thing that we have been doing when we have powers. You bring the 1 down, you multiply it by the constant, so it becomes 1 times 1 x to the power. The power, you have to subtract 1 from it, so it becomes 1 times 1 x to the 1 minus 1. X to the 1 minus 1 is 0, and x to the 0 is 1. So it becomes 1 times the constant, it becomes 1. That's why f prime of x is 1, or f prime of y, when you have derivative in respect of y, it becomes 1. One variable without a constant, or with a constant of 1 and a power of 1, it becomes 1. That's why we get 1 when we differentiate x alone. Let me give you a tricky example. Let's say we have this. Let's say we have f of x equals square root of 4x. Does this have any powers? Well, actually, yes. This square root right here, we can turn it to a power because the power of this function for the 4x is 1. Here we have a 2, so this becomes 4x 1 over 2. Basically, you take the power of the function inside and then you put it on top, just like here. You take the power of the square and then you put it underneath. It becomes a square, right? So right here we have 4x to 1/2. We have a power, and as you can see, this power is less than 1. In the previous examples, we had powers that were more than 1. Now we have powers that are less than 1. So how do we solve that? Well, again, it's extremely simple. All you have to do is, so for example, the 1/2 power of 4, or the square root of 4, is 2. So we take this 4 out and it becomes 2. So it becomes 2x, and the power of x is still 1 over 2. So it becomes 2x 1 over 2. So what we did, we just simplified it before we take the derivative. So what is the derivative of 2x 1/2 to the 1/2? How do we find that? Well, again, it's extremely simple. All you have to do, we know this, we take the 2 out, it becomes 2f prime x to the 1/2. Okay, so far so good. And we take this half, we multiply it by the 2, and then we take 1 of the half. So half minus 1, it becomes minus half. So what we get is 2 times 1/2 times x to the minus half. This is what we get. Why? Because here, as you see, we have a 2, we have f prime of x to the 1/2. So if we want to find the derivative of x to the 1/2, all we have to do is to bring the 1/2 down, multiplied by our constant, and take 1 off the power of the x. And this is exactly what we did. Half minus 1, it becomes minus half. So this gets more simplified. This 2 will go with this 2 because half times 2 becomes 1. And this x to the minus 1/2, you put it underneath, it becomes x to the half, and x to the half, just like here, is x under the square root. So 2 times 1/2 times x to the minus 1 over 2 is 1 over square root of x. So as you can see, anytime you have a power, all you have to do is to bring the power down, multiply it by the constant, take 1 off the power, and then ta-da, you get your derivative. The derivative of a function f with a constant c and a power p not equal to 1 is cp times the function with p minus 1 power. And this is about the power rule. Let's check out the next rule.